We're going to be rationalizing the denominator of a fraction. Rational expressions must contain a rational denominator. Therefore, radicals, because they're irrational, cannot be a denominator of a fraction. So let's do a couple examples. We're going to use smart ones again, and we're going to use the example of 2 over radical 5. If you look at it, the radical 5 is in the denominator. Now, an easy way to do this is to always look at the index, and I say, okay, the index is a 2 because it's a square root. And you've done a lot of these before, so it's almost innate where we say, okay, this is my smart 1, because radical 5 over radical 5 is 1. If I multiply this fraction by 1, I don't change it, but I can change how it looks. Now, you do this, when you say radical 5 times radical 5, you multiply your innies, you get radical 25, which is 5. Okay? But the other thing I want you to notice is because your index is 2, I have to have 2 5s. And because I have 2 5s, when I multiply them together underneath the radical, it basically cancels the radical out and it makes a 5. The numerator doesn't look as pretty, so my numerator is now 2 radical 5 over 5. And if you don't believe me, you can put this in your calculator and check. 2 divided by radical 5 is exactly the same as 2 radical 5 over 5. This has just been rationalized. I gave it another example. I have 9 over 4 radical 3. Well, the only thing that's irrational in the denominator is the radical 3. The index is 2, so I need another radical 3 to multiply it by. So you put that here, and then it's radical 3 over 3. That's my smart 1. Multiply this whole fraction by 1. So I have 9 radical 3 on the top, and the denominator is 4 times, this comes out to be radical 9, or 3, 4 times 3. That's what the denominator comes out to be. So I did what I wanted to do. I want to get rid of the radical. So now my fraction is 9 radical 3 over 12. At the very end, you can simplify this, and as you can see, 3 goes into 9 3 times, 3 goes into 12 4 times, so my answer is 3 radical 3 over 4. All right, let's try a couple more examples. All right, I picked cube roots because this is, I think everybody is pretty good with the square roots, so we're going to practice them with cube roots. So I have 3 divided by the cube root of 16. Now, again, this is an irrational denominator. I cannot have a radical in the denominator, but now it's not square root, so it's not so easy. What do I do? Well, you have to look, my index is 3, so I need to have 3 of something so that I can get rid of that radical, okay? So if I were to factor this out, I would have a 4 and a 4. And I could factor it out even more if I wanted to. But right there, I have 2 4s. So what I need to have is at least 3 4s so that I can get rid of the radical. So I'm going to multiply it by the cube root of 4. Now, if that is my denominator, it also has to be my numerator because, remember, it's a smart 1. It has to be 1. So when I multiply this, the numerator, of course, isn't that pretty. It's 3 cube roots of 4. But the denominator, I have 4 times 4 times 4. There's 3 of them, so the denominator is just 4. You've gotten rid of the cube root part. And that would be my answer. This has the same value, but it's been rationalized as 3 over the cube root of 16. All right? Let's try another cube root 1. Let's look at this one here. Now, this one here, you can do this a couple ways, but I have the cube root of 4 in the denominator. I don't really care about the numerator right yet. I have to rationalize the denominator. So if I look at it and if I break this down, I have a 2 times 2. So I have 2 2's. I need to have 3 2's because my index is 3 to get rid of that cube root. So I'm going to multiply this by the cube root of 2. You do not need to use the 3 again. The whole idea is you're just trying to get rid of that radical. So now the top is going to be the same thing, the numerator, because this is my smart 1. So when I multiply that out, I have 2 cube roots of, I have to multiply my innies, 6. So the top is 2 cube roots of 6 in my numerator. My denominator is going to be 3 times, I have 1, 2, 3, 2, so that's 2. So I end up with 2 cube roots of 6 all over 6. And my outies can be simplified even more. So I have the cube root of 6 all over 3 for an answer. Okay, now let's try some with binomials. Okay, now this is also should be a little familiar to you, but we're going to be rationalizing using the conjugate this time. The conjugate, if you remember, when we had parentheses, when you multiplied it by the same thing, and you guys are used to hearing it as front seat, back seat, is everything in the parentheses are exactly the same except your sign's different so that the middle disappears when you multiply those out by using distribution. Well, it works the same with radicals. So now I have a binomial in my numerator. My denominator. So what I have to do is get rid of the radical. Well, I can't just multiply by radical 7 over radical 7 because I'll still end up with a radical when I do the distributive property. It won't work. So I have to use the conjugate to get rid of it. So what you're going to do is look at the denominator, rewrite the same thing, but change the sign. Now, if I'm using a smart 1, the numerator has to be exactly the same. So there's my smart 1. Now let's multiply that out. Now the denominator should look beautiful now. It should look really nice. So I look at it, I got 3 times 3 is 9. Now let's multiply the middle out. I got 3 times a negative radical 7, so that's negative 3 radical 7. Then I multiply this, I have a positive 3 radical 7. Well, they cancel each other out. That's exactly what we wanted to have happen. So it's gone. Good. Now I have to multiply radical 7 times a negative radical 7, which comes out to be a minus 7 because my index is 2 and I'm multiplying it, and it comes out to radical 49, so that's 7. So my denominator actually comes out to be 2, which is beautiful. Now the numerator, again, doesn't look so pretty, so we got 2 times 3 minus radical 7. Now I know your urge is, I want to multiply that through. Please leave it in factored form if at all possible, because if you see this here, I see that, oh, these are factor, these can cancel out, so my answer is just 3 minus radical 7. This is exactly the same as that if you were to put it in your calculator, but this has been rationalized because there's no denominator, no radical in the denominator. Okay, let's try one more. This one right here, I got 4 plus 5 radical 2, so I'm using the conjugate. Has to be the same. So my denominator should look pretty. Let's look at it. I got 4 times 4 is 16. The middle disappears, and then I have minus 25 times 2, because radical 2 times radical 2 is 2. So the denominator actually comes out to be, on this one, comes out to be a 16 minus 50, or a negative 34. Okay? Now the top, we have to actually, the numerator, we have to actually distribute. So I have 12 minus 15 radical 2 minus 4 radical 2. Oops, I'm running over here. Minus 5 times 2. So that looks kind of ugly. So let's look at that. My numerator is 12 minus 19 radical 2 minus 10. All over negative 34. These two can go together, so I have 2 minus 19 radical 2 all over negative 34. Okay, now that should help you. This one, that's why we did all that review before, so that you can multiply and double distribute and practice multiplying radicals.